All right, and welcome back. In this video, we are going to be going through Chapter 8, Section 5, titled The Tangent Ratio. This is the first of three different ratios that we will be talking about moving forward. By the end of this video, we should be able to define the tangent ratio for acute angles, as well as solve right triangle problems by use of the tangent ratio. Now, before we move on, I talked about having one of three ratios so far. Eventually, we are going to be talking about something that you can remember by SOHCAHTOA. Today, we are talking about the tangent ratio, so the TOA of it. And SOHCAHTOA is something that is a memorizing device in order to use these three different ratios. And today, we're talking about the tangent ratio, or the TOA of SOHCAHTOA. And this will make a lot more sense as we go through the chapter, I promise. So in right triangle ABC, the leg opposite of acute A is BC, and the leg adjacent to angle A is AC. The tangent ratio is the ratio of the lengths of the legs. So we can write it as the following. The tangent of angle A is the leg opposite of angle A over the leg adjacent to angle A, or BC over AC. Tangent of angle B is going to be the leg opposite of angle B over the leg adjacent to angle B, or AC over BC. And its easy to remember form is tangent is equal to the opposite over adjacent. T is equal to O over A, TOA. In example number 1, we are asked to express tan of P and tan of Q as ratios. Well, for tan of P, it's going to be QR over PR, which is 15 over 8. And tangent of Q is going to be PR over QR, which would be 8 over 15. Notice how our hypotenuse of 17 is never used at all. With this in mind, please work on problems 1 through 4 on the guided notes and resume when you're ready to move forward. So the table on page 202 gives approximate decimal values of the tangent ratio for some angles. In example 2a below, the table is used to find tangent of 20 degrees is approximately 0.3640. That sign means approximately equal to. So it's a equal sign that has some squiggles to it, which means approximately equal to. Many calculators also give approximations of the tangent ratio. And the table can also be used to find any angle measure given a tangent value, as in example 2b below. Many calculators use inverse keys, such as inverse tan or tan to the -1, to get values for angle measures for a tangent value. And we'll be talking about those in a little bit. In example number 2, we are asked to use a table on page 202 to complete. So we're asked to find tangent of 20 degrees is approximately what decimal, and tangent of what angle is approximately 4.0108. So for solution for number A, for step 1, we're going to locate the 20 degrees in the angle column. Step 2, go across to the tangent column and read that the value given is 0.3640. For B, we're going to locate 4.0108 in the tangent column. Likewise, now go across to the angle column and identify that the value is going to be 76 degrees. So tan of 76 is approximately 4.0108. With this in mind, please work on problems 5 through 10 on the guided notes and resume when you're ready to move forward. In example number 3, we're asked to find the value of x to the nearest tenth. So looking at this, we have a tangent value. We're going to have 65 is our angle, our opposite is 7, and our adjacent is going to be a length of x. So tan of 65, we can write it as tan 65 degrees is equal to 7 over x. And you can solve this equation, or you can find the measure of angle B and write an equation that is easier to solve. So the two methods that we are going to be going through, on the left-hand side, we can use method number 1. We can say tangent of 65 is equal to 7 over x. And tangent is a function. It is a function. So whenever we're talking about inverse, we'll have to get there. But it's the inverse of a function. So if we want to get the 7 all by itself, we multiply both sides by x. and then we divide by tangent of 65. So x is going to be equal to 7 divided by the tangent value of 65 degrees, which means that x is going to be approximately 7 over 2.1445, or x is approximately 3.2641641, or just 3.3. In method 2, we can find the measure of angle B, which is going to be 90, take away the measure of angle A. So we have 90 minus 65 is going to be 25. So the measure of angle B is now 25. Well, tan of 25 is equal to the opposite over the adjacent, so tan 25 is equal to x over 7. We can multiply both sides by 7, and we're going to end up with x is equal to 7 times the tangent value of 25 degrees. Tangent value of 25 degrees is approximately 0.4663, which means we do 7 times that approximate value, and again, we end up with x is approximately 3.2641, or 3.3. With this in mind, please work on problems 11 through 14 on the guided notes and resume when you're ready to move forward. Example number 4, we want to find y degree correct to the nearest degree. So remember how we said that tangent was a function. On A, we're trying to find y degree with have legs of 5 and 4. For B, we're trying to find the value of one of the legs, which is x. We are given the other leg, which is 5, and we're given the hypotenuse, which is root 89. For A, the way that we're going to solve this is the tan of y degrees is equal to 5 over 4. So it's going to be 1.25. So both tangent of 51 and 52 are close to 1.25. And now we have to figure out which is closer. So the tan of 51 is equal to 1.2349. Might I add, I'm very upset that that 9 is not a 5, because then it would be 1.2345, but regardless. So the tan of 51 degrees is equal to 1.2349. So 1.25, the given value, minus 1.2349 is 0.0151. Tan of 52 is equal to 1.2799, and the difference there is 0.0299, and 1.25 is closer to 1.2349 than it is to 1.2799. So the y's degree is approximately 51. Over for B, we have tan of y degree is going to be equal to 5 over x. So first we have to find the value of x. Well, x squared plus 5 squared is going to be equal to root 89 squared, because we can use the Pythagorean theorem. We end up simplifying that down, and we eventually get that x is going to be equal to 8. Now that we know that x is equal to 8, we can use the tan of y is going to be equal to 5 over 8, which is the same value in a decimal as 0.625. Using the table, we find the closest value to 0.625 is approximately 32 degrees. So 32 degrees is approximately going to be our degree of y. With this in mind, please work on problems 15 through 18 on the guided notes. Keep up the great work. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.